Hello everyone and welcome to the channel. In this video we will be discussing about mass spectrometry. We will be going into a very brief introduction of this and we will be generally stick to the application part of this, that is we will be solving questions which are coming in CSIR exam from the mass spectrometry. If you see the previous examinations, like previous question papers, you will see that earlier questions from mass spectrometry directly they don't ask you questions from here, but by the time the pattern has been changed, the examination pattern is changed, that is from June 2017, you will see that in June 2017 also and in December 2017 also they have asked a direct question from mass spectrometry. So this become a very essential and very important topic to be understood and to be solved. Okay, so in this video we will try to understand it in like very basic way and try to do the questions which are coming from it. So when we talk about mass spectrometry, what mass spectrometry is, it is a very essential and very important technique to check whether the compound, whether the molecular structure which we are expecting from a particular compound is correct or not. So this is one of the most important characterization technique. By NMR and all you can reduce the structure of compound, but from mass spectrometry you can check whether that structure is correct or not, and you will get sure shot correction or sure shot answer from that. Okay, so that makes it very important for all the chemists. So when we talk about mass spectrometry, what it is done in mass spectrometry, first of all we take a sample, we vaporize the sample, we ionize them, and then we smash it into bits. Okay, like it gets smashed into small bits. Then we pass it into a tube which is having like electric field and magnetic field, and due to the different masses, and they will contain, the bits will contain certain charge, so due to their mass by charge ratio they will be deflected by certain different angles, and the detector will detect them and it will tell the intensity and that how much particles of which size or which mass are there in the compound. So if you'll see mass spectrometer data, it will be like this. Okay, I have taken a compound that is 2-chloropropane, and for that this is the mass spectrometric data. So when you will see that on the x-axis you have relative intensity, and on on x-axis you have mass by charge ratio, and on y-axis you have relative intensity. Relative intensity is high, that means that certain fragment or that certain bit is more in number. Okay, and if mass by charge ratio is more, that means the mass of that bit or mass of that fragment is more. Fragment is the part which get smashed out. Okay, smashed out. So if we have this compound, let's say we have this I'll do it here only, let's say. So if I have this 2-chloropropane and I smash it and I take it out, I take out the chlorine from here, so what I will get one CH3. Okay, and this is called radical cation that I will get. So a radical cation of this compound I will get from here. Okay, generally this chlorine will be containing that charge, but nevertheless I'm just telling you in the brief. Okay, so what will be the mass for this fragment? Let's check it out. So for each carbon the mass is 12, so 12 plus 3 is 15, and this will also give you 15. 15 plus 15, that will be 30, and this will be 12 plus 1, that is 13. So 30 plus 13 is 43. So 43, this peak, this correspond to this fragment. That means, and the intensity of this peak is very high, that means this fragment lies in very large amount. Most of the fragments are of this only. Okay, similarly if you take whole compound, whole molecule, and if you add the mass of that, so like from here onward you got 43, and if you add 35 of this chlorine, then what you will get? You will get 78, and the peak at 78 you are getting. So that denotes that this is the molecular peak, means the whole molecule shows peak at 78. Now the thing is that there are certain isotopes which are available. Okay, so we have a isotope of chlorine which is having molecular mass of 37. Okay, so we have 2 chlorine, 35 chlorine and 37 chlorine. So if we have 35 chlorine, we will get a mass peak at 78. But if we have that chlorine, if this chlorine was not 35, if it would be 37, then we would have got that peak at 80. So that's why we are getting some of the peak at 80. That means the only chlorine 35 is not here, there is some bit of 37 chlorine also here. So that depends on the intensity of this, that depends on the abundance of it. So the abundance of carbon like chlorine 35 is like 75% nearly, and for chlorine 37 it's 25%. So both of them lie in a ratio of 3:1. So that's why the intensity of their peak, the peak which we get due to them, is also approximately 3:1. So this is the basic idea of it, and like this is the only thing. You can just break it into different pieces, and you can add the mass of that, and you can check that you are getting mass like peak at that place or not. Okay, so this is mass spectrometry. This is the basic of it. But the question they will ask you, like what I have seen, the questions which are being asked are from the relative abundance, then the peak ratio, then McLafferty rearrangement. McLafferty rearrangement is one of the very important rearrangement technique which is generally used by like in mass spectrometry. And you will see here like most of the organic compounds they will show, which will show this McLafferty rearrangement, the questions will be asked from there only. Okay, so let's try and understand what that McLafferty rearrangement is. Before going to that, I will just tell you one or two more things which will help you to like in, if you are in your masters and if you are solving questions in which the mass spectrometry data is given and you have to deduce the structure of it. So there are certain things which you should keep in mind, that if the relative intensity ratio is 3:1 and you are getting m plus 2 peak, m plus 2 peak is like this. Here you are getting 78 molecular peak, and 80 was also you are also getting 80. That means m is the molecular peak and m plus 2 means you are getting a peak 2 more than the molecular peak. So if you are getting m plus 2 peak and the intensity of those peak is 3:1, then then it is confirmed that the compound will contain at least one chlorine. Okay, if you are getting m plus 4 peak, that means two chlorines are present. Okay, and if the relative intensity is 1:1, then bromine is present. Okay, so these are certain very basic things which you should know if you are in your masters and the questions come from there. Okay, in masters there are like, if you have opted for the spectroscopy course, then you must have studied about these things along with NMR, IR, and you have to study about mass spectrometry also, and there these things help you a lot. Okay, so if you get m plus 2 peak, that means some halogen is there, either chlorine or either bromine. Now if it is chlorine or bromine, that will be confirmed by the relative abundance. Okay, if abundance is 3:1, that is chlorine. If it is 1:1, that is bromine. Okay, if you are getting m plus 4 peak, that means either it will be 2 chlorine or 2 bromine. Then also you will be like confirm it, you will get it confirmed by the intensity of the peak. So this was all about like the basic of it. Let's check it, let's like understand what McLafferty rearrangement is, and then we will go to the questions. Okay, so let's talk about McLafferty rearrangement. This rearrangement is very common fragmentation reaction which is observed in mass spectrometry. So the basic thing, the basic requirement for this rearrangement to be done is like the molecule should be like this. Okay, the molecule in you are taking the molecule which will give McLafferty rearrangement should have conformation like this. What it is like, you should have alpha, beta, gamma. You should have at least one gamma hydrogen. Okay, means at your gamma carbon there should be one hydrogen. And what Z over here is, this Z is it can be carbon, nitrogen, or oxygen. Okay, so at the place of Z you can have carbon, nitrogen, or oxygen. So if you have this like this is the thing, if you get this thing, then McLafferty rearrangement is sure. There will be McLafferty rearrangement for sure. Okay, I will be solving one question and I will tell you how it will be done. So here I have given few examples. Like if the place of Z there is C, that is CH2, then the molecule will look like this, and you can see alpha, beta, and gamma. At gamma carbon there could be more carbon also, but at gamma carbon there should be at least one hydrogen. Okay, similarly here at place of Z there is oxygen and alpha, beta, gamma hydrogen. Similarly here at place of Z there is nitrogen, alpha, beta, gamma. Okay, so this is the basic requirement for McLafferty arrangement. Now let's check out the mechanism of it. Okay, so let's say we have this molecule and it satisfy all the conditions for McLafferty rearrangement. We have gamma hydrogen also, and here we have oxygen also. So when we bombard electron on it, that is we ionize this compound, what we will get? We will get like, okay, so we will get a radical cation over here. Okay, so a radical cation at this place. Now what will happen here? Rearrangement will take place. How the rearrangement will take place? See, I'll just name it alpha, beta and gamma. It is very essential to know that which bonds will break and which will get formed. Okay, so first of all, the first rearrangement will happen is this bond will be done homolytic cleavage. Okay, so it will be done like this, something like this. Then the bond between alpha and beta carbon, it will break. Okay, it will be like homolytic cleavage over here also, and this cation, radical cation, will attack on this proton, or it will trap this proton, and proton will form a bond with this oxygen. So what you will get? You will get, see, here you have like a single bond was there, and one electron from here and one electron from here, so that two electrons will form a bond. Okay, so you get a alkene here. Plus what else? So we were having like this, like nothing has happened here, then single bond here, oxygen is here, and oxygen has formed a bond with this proton. Okay, and okay, and what has else? One radical cation, one free radical was formed here, and this was the carbon carbon double bond. Okay, so like this. Now what will happen again? This is not that stable compound. Now again rearrangement will happen, and wait, we are having one plus charge. Okay, so now again rearrangement will happen. What will happen? This will go there and this will go there. Okay, this pi bond will get homolytic cleavage, and this free radical will go to form a bond here. So here this alkene will be like that only, and we will get, okay, so that radical cation on oxygen, which was already here. Okay, which here also we were having. So that what we got. Okay, so this is called enol radical cation, enol radical cation. Okay, so this is the mechanism of McLafferty rearrangement. You don't have to do many things like this. This seems to be a little tricky, but nothing is happening. Just what is happening, you have to break the bond between alpha and beta carbon. Okay, split the other things which are there that side, just take it out. Okay, so that will be gone. And what else you have to do? You have to form a bond between this oxygen, or if it would be carbon, then this carbon and this gamma hydrogen. If it would be nitrogen and this gamma hydrogen. So whatever here it is, you just have to form a bond with this gamma hydrogen and just form the double bond, like you have to make the enol radical. Okay, so like this McLafferty rearrangement occurs. So now let's try to solve few questions which were asked in CSIR exam based on these things. Okay, so now let's take a problem from CSIR December 2015 exam and we'll try to solve it. The question says that the mass spectrum of 1,2-dichloroethane, the approximate ratio of peaks at m by z value 98, 100 and 102 will be. So the compound given here is 1,2-dichloroethane. Let's quickly make it. So it will be CH2, CH2, Cl and Cl. Okay, so this is 1,2-dichloroethane. Now this chlorine will play the role here. Okay, because as you can see the difference in these masses, like you are getting m, this is the molecular, like if you calculate the whole mass of the molecule, you will get like 14 from here, 12 plus 2 hydrogen, that will be 14 plus 14, you will get 28, and plus 35 from here and 35 from here, you will get 70 here, so you will get 98. So 98 is the molecular ion peak. Okay, so this you are getting due to whole molecule. Now you are getting, see, you are getting m plus 4 peak. M plus 4 means 98 plus 4, that is 102. You are getting this peak also. That means you in your molecule there are 2 chlorines, that is already given, but if only data is given, then also you can you can think of it. Okay, so okay, so we are having 98 and 100 and 102. These 100 and 102 will be possible if the chlorine will be present in isomeric form also, sorry, isotopic form also. Okay, means like if you have both the chlorine as 35, like I have done, if it would be 35, then the overall mass would be like the sum of the chlorine, mass of chlorine will be 70. If let's say you have one chlorine 35 and other at 37, then your mass will be like 35 plus 37, that will be 72, and you will get 100. And if both of the chlorine would be 37, then you would have got 74 here, so 28, that is for this fragment, that will be common, and you will get 74 from here, so 102. So this 100 and 102, that both of them you are getting because of the isotopes of chlorine. Now you have to answer, you have to check that which will be the correct ratio of the peaks. Okay, what will be the ratio of the peaks? That means what will be the relative abundance, ratio of the relative abundance? That will be that will be calculated according to the relative abundance of the isotopes only. So this fragment is doing nothing over here, that is common for all the three things, so we can that will not affect the peak anymore. The thing which affect here, that is the isotopes of this chlorine. So we'll try and solve these questions with the help of that only. Okay, so first of all we will take the case where both the chlorine are 35. Okay, so if both Cl are 35 Cl, okay, so then the mass, then the peak we will get at 98. For that, what you have to do, you have to just take the abundance of this. I have already told you that the abundance of 35 Cl is 75%, and for 37 Cl it is 25%. So like for calculation you can take it as 0.75 and this as 0.25. So in the compound we are having both of them as 35 chlorine. So here it will be calculated as 0.75 into 0.75. We are multiplying both of them because both of the atoms are present in same molecule, and we are multiplying their relative abundance. Okay, so if you will multiply these two values, you will get around 0.5625. okay, it's very easy to multiply, you can do it yourself. Like now next, it can happen that one Cl35 and 137 Cl. Okay, so like this you can take. So what will happen there? You could have two possibilities. One is CH2. This could be like Cl35 and this could be Cl37, or you can have CH2 and this could be Cl37 and this could be Cl35. See, like you cannot say that both of them are like equivalent only. In mass spectrometry, that means that first this fragment is getting broken and then this. Okay, here first this is getting broken and then this. So you have to consider both of them, both of the cases. Okay, so like say how the calculation will be done for it. For 0.35 we have relative abundance of 0.75 into, for 37 we have abundance of 0.25. okay, so this is done for this molecule. Then add for this molecule also 0.25 into 0.75. so when you will solve all these things, you will get around 0.1875 for this, and similar value 0.1875 for this also. If you will add it, you will get 0.375. okay, for this. For if both for the chlorine were 35, you would have got this. If one of 35 and other 37, you would have got this. Now the next and the last condition is if both of them are 37 chlorine. okay, so what will happen here? Like this CH2 and this chlorine is also 37 and this chlorine is also 37. So we will multiply the relative abundance of them, 0.25 into 0.25, so you will get 0.0625. so like this you have got the three values. First one is this, second is this and third is this. Now check the ratios, okay, given in the question. Now If you don't want to solve it further, here also you can get the answer. Okay, you don't have to solve it further. Like from this much data also you can predict the answer. See how here you are seeing that the for first, like for 98, when you are getting 98 m by z, the relative abundance value is very high. Okay, the multiplication you are doing is 0.5625. Now when you are doing for 100, you are getting 0.375, and for 102 the value is least, that is 0.0625. Means for this the value will be highest, then this and this, so the ratio will be also in this order. See, for first option the two ratios are equal, that means this and this should be equal, which is not here, so this is not correct answer. Okay, this can be cancelled out. Let's check out for third also. It says first and second should be equal, so but it is not equal, both are different, so this can also be cancelled out. And the fourth one says the first and last one are equal, like ratio are equal, that means they should also be equal, but they are not equal. Okay, so that means it is also cancelled out. Only the option 2 is telling that the first will get highest, then the second one, and then the last one. So the correct option from here, from this much data also you can predict it is second option. But if you want to get the exact answer, if you want to get the exact ratio in whole number, you just divide all the three values with this value 0.625. you just divide it with this, all these three, and you will get this value. Okay, so divide it and check it out that whether you are getting or not. We will move on to the next question. Okay, so let's take another question which was asked in June 2017, and I think this question was asked for 4 marks. I don't remember exactly, you can check it out. Okay, so this question says that the mass fragment of IRCl, IR is iridium chloride, in mass spectrometry shows 3 mass peaks at m by z 226, 228 and 230, given that the natural abundance of, okay, so here we are having like isotopes of IR also and isotopes of chlorine also, so they have made the thing little difficult, but doesn't matter, we will do it also. Okay, so what three masses we are getting? We are getting 226, 228 and 230. Okay, and we are getting due to IRCl. Okay, and what masses of IR and Cl are? IR exists as 191 also, and IR exists as 193. Okay, and similarly Cl exists as 35 and Cl exists as 37. Now you have to check that how you are getting this 226, how you will get this 226. So in order to get this 226, you can, like, you have to do the hit and trial, you have to check that how you are getting. So for 226 I have done, and I will just tell you that if you take IR 191 and Cl 35, like if you will add these two, you will get 226. This is the only way of getting 226. Okay, so for 226 we have this. Now let's check out for 228. For 228, what you can do, you can either take IR 191 and Cl 37, either you can take this, then also you will get 228, or you can take IR 193 and Cl 35. Okay, then also you will get 228. So in order to get 228, you have two options to get it. Now the next one is 230. In order to get 230 as m by z, you have only one option, that is IR 193 and Cl 37. So if you will take these two, then only you will get 230. Okay, so this much you have to do, and then you have to follow the similar way which we have done earlier. Okay, so what you have to do, like for the first one, for 226, IR 191 and Cl 35. So for IR 191, the abundance is 37. So we will take as 0.37 into Cl 35. For Cl 35, the abundance is 76. So 0.76. Just multiply them and check the answer. Okay. Now for like 228. For 228, you have to take IR 191. For IR 191, the abundance is 37. So we will write it 0.37 into Cl 37. The abundance is 24. Okay, but all the things are given in question, all the abundance and everything. You just have to multiply and solve it. Plus, now you have to take IR193, the abundance is 63, so 0.63 into Cl35, the abundance is 76, so 0.76. Multiply and add it. I will just write the values, okay? You just do it. Like, you can pause the video and you can solve, or I will be doing it like right away. For 230, we will take IR193, abundance of this, that is 63, means 0.63 into Cl37. For Cl37 we have 0.24. So when we will multiply this, we will get, okay, so when we will multiply these things, here we will get 0.2812, here you will get 0.0888, here 0.4788, okay, multiplication of these two, and when you will add it, you will get 0.5676. For this question you will get 0.1512. Okay, so by calculating all the three values, you have, like, by now you have understood that, see, the middle one value is the highest one, then comes the first one, and the smallest is the last one. Now by this much data only you can get the answer. See, in which of the option the middle one is highest one, in first and in third, okay. And now check the like, middle one should be the highest one, and first one should be the next smallest one, and the third one should be the smallest, least one. So that is for that is only available in option number 1, means the second option is the highest one, then first one, and the least one is the third one. So like this, in this way, by simple calculation you can do these mass spectrometry questions. So this is very easy question. Similar concept, 2 questions have been asked, and it is very essential for practicing this type of question, because probability of this type of question to be there in next few examination is very high. So I'll suggest you to practice more and more question from this topic, okay. We'll take one more question which was asked in CSIR December 2017. Okay, so let's take one more and last question from CSIR December 2017 exam. The question says that among the following compound that gives base peak at M/Z72 in AI mass spectrum is. Now these are the 4 options, and you have to select that which option will give you base peak at M/Z72. Okay, so like, see, I have already told you that that McLafferty rearrangement is generally asked. So if you get if you get any ketone or alkene, like unsaturated compound alkene, like, or like you get this at this position NH, then you should like there should be in your mind that, okay, there should be McLafferty rearrangement somewhere, okay. Now if you will check the molecular ion peak of all of these like molecules, you will not get 72, you will get more than 72. And if you will fragmentize and then also try, then also it's difficult to get 72. So what the correct way of doing this is the McLafferty rearrangement. We'll try and to do that with McLafferty one. So for McLafferty rearrangement, the basic thing is like double bond and like oxygen, carbon or nitrogen. That is all in all the 4 options. The second and most important thing is presence of a gamma hydrogen. So let's check it out. In which option we are having gamma hydrogens? So we have alpha, beta, gamma. Okay, so here in gamma we have 2 protons. So this is like a potential like answer. It can be potential answer. Now let's check out here alpha, beta, and we have 3 gamma. Okay, and all gamma are having hydrogen, so this can also be the option. Now let's check out here alpha, beta, and again 3 gamma. All are like, here also beta, gamma. So we have 1, 2, 3 and 4 types of gamma. So any of them can be like undergo, sorry, I have named it, sorry, this is alpha, this is beta, 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 this is also alpha, and this is beta. So there is no gamma hydrogen over here, okay. I was a bit okay, no problem. So like, there is no gamma here, okay. So only alpha and beta hydrogens are here, so this cannot undergo McLafferty rearrangement, so just eliminate this. Now let's check it out for this. So alpha, beta, gamma, and gamma, we are having 2 gamma and 2 potential answers here. So let's check out from the option 1 that whether we are like, how, if we will undergo it McLafferty rearrangement, what we will get. So for the first option, I will try to do the mechanism wise. What will happen? See, double bond. Oh, it's recommended that you follow the mechanism because like that the probability of doing it wrong is less. Okay, so here are the two protons, gamma protons, alpha, beta, gamma. Okay, so first of all, like, I'm not doing the first step. In first step, that electron is bombarded and we are getting a radical cation here. Okay, now what will happen? What I have told you, that alpha and beta bond will be broken, and this proton, gamma proton, will also get broken and it will form a bond. So what you will get? You will get something like this: double bond O, then H plus charge. Okay, this is not nothing, this is just by mistake. These are the lone pair of electrons, and here, and what you have got here, double bond and this. So you have got one fragment here and one fragment like this. Okay, now let's do the rearrangement which is possible here. So what will happen? This radical will go like this and like this. Okay, so what you will get from this, you will get a enol radical. Okay, so this is what you will get, an enol radical. Now let's check out the molecular mass for this. So if you'll check the molecular mass of this will give you, see how many protons are here. One proton is here also. So this is basically CH3, this is CH3. Okay, so CH3 means 15, this is also 15. 15 plus 15 plus 1 carbon, that is 12, plus 1, that is 13. This is 1 carbon, that is plus 12. 1 oxygen, oxygen is how much? 16 plus 1. So let's add them together, 30. Okay, and then 16 and 14, that will give you 30. 30 60 plus 12, that is 72. So this fragment is giving you 72. So the option 1, you have done McLafferty and you have got one fragment which is giving you 71 in the m by z value. Now check out for the others also and check it out whether you are getting 72 or not. I am not doing this so that the video will not, like, I have already done and I have seen that they are not getting, and they are not giving 72. Okay, but for your satisfaction you can check for them also, and that will give you a little practice of McLafferty also. Okay, so I'll suggest you to do for like at least for 2 and 3. Fourth will not undergo. So you can try 2 and 3 and check whether they are giving you this m by z value 72 or not. For me, the correct answer is option number 1. So in this way, this is the way of doing the questions from mass spectroscopy. I hope you like the video. I hope, like, many of you were asking for this to make a video on mass spectrometry. So that's why I have made this, and thank you for watching. Thank you for subscribing. Thank you for giving so much love to the channel. And I request you that if you haven't subscribed the channel, please subscribe it. I'll be bringing more videos, more important things for you for CSIR exam and for other things also, for other examinations also, like GATE, and I'll be starting soon for JAM also. So thank you for watching, and if you want to ask anything, you can ask in the comment section. So that's all for the video. Thank you for watching.